Welcome back, gang. If I seem a little sad right now, it's because I am. This is the third time I'm making this video because the previous two times the program crashed. That's okay. I love talking about the domain. I'll talk about the domain all day. Again. So let's do this. I'd like to say that this may be a video that you come back to from time to time because for whatever reason, students seem to have a hard time figuring out what the domain of a function is. And I hope that after this video is done, you realize that it's very, very simple. There's only two things you have to worry about. Figuring out what the range is a little bit different because you have to know something about the functions. But the domain is a piece of cake. So what I mean by the domain is what x values can you use that give a valid output? Well, what's an invalid output? An invalid output is one that results in something that's undefined or something that's not real. Those are really the only two troublemakers you have to worry about 95% of the time. And when the time is right, I'll tell you about the other 5%, but you don't have to worry about that right now. So, how do we handle this? What does it look like to have those two issues? Well, if you have a quotient with an x in the denominator, then it's possible that the denominator is 0 and you cannot divide by 0. So that's one issue. The other issue is if you have a radical, specifically an even root, you can't have a negative within an even root because you get an imaginary number. Okay, you can have a negative under a cube root just fine, just not even roots. So I'm going to take those two issues one at a time and address them so that you understand, okay, I know how that happens, but how do I figure out what x can't be? And we're going to start off with this very simple equation, 3 over x squared. Okay, and every time you come across these problems, you're thinking of two things. Is it possible that there's a 0 in the denominator? Is it possible that there's a negative under an even root? In this particular case, we have an x in the denominator, and that means that there's a potential that you divide by 0. So we have to figure out what can't x be? If I don't want to divide by 0, what do I have to restrict x to? Okay, in this case, it's pretty simple because it's just x by itself. X can't equal 0. If x equals 0, you have 3 divided by 0, which is undefined. Okay, and that's fine and dandy for this particular case, but what if it's not just plain old x or x squared on the bottom? How do you handle that? All you do is you take whatever's in the denominator and set it not equal to 0, and then simplify it. Whatever's in the denominator, set it not equal to 0, and then simplify it. So in this particular case, we would just say x squared cannot equal 0, which would still result in us knowing that x cannot equal 0. All right, so our domain, if we're writing our domain, we would write all the reals such that x does not equal 0. And to be honest with you, this part, the reals, that doesn't bother me so much. This is more of what I'm looking for. So if you include the real symbol, fine. If you don't, it doesn't matter to me. It may be different for other teachers, so don't take that as gospel, but know what your teachers want expecting from you. Okay. All right, so let's up the ante a little bit. Let's take a look at something that's a little more complicated than the last. Okay, we have x plus 2 in the numerator, x squared minus 2x minus 3. Okay, our rule doesn't really care about the numerator, especially in this case. We're just supposed to set the denominator not equal to 0. Okay, we can do that. And then some of you get to this point and you think, oh no, I have to factor. I can't factor. Stop it. If you have to come into my room after school for 7 weeks straight to learn how to factor, then doggone it, you do it, because you have to know how to do it. This one is x minus 3x plus 1. Then that means that x cannot equal -1 and -3. It's everything except -1 and 3. And how do we write that? Like that. And again, writing down the real symbol doesn't much matter to me. Okay, so that's how to handle the first possible scenario where you divide by 0. What about that radical one? Okay, for there, it's almost as simple. You just take what's under the radical and you set it greater than or equal to 0. Okay, because you can take a square root of a 0. It's just 0. So you include the 0 on there. Just take what's underneath and set it greater than or equal to 0. So, in this case, x plus 2 is greater than or equal to 0. And that obviously turns out to be x is greater than or equal to -2. So I hope that there's some agreement with you guys that, boy, if those are the only two things you have to worry about, it's not that difficult. And that's the truth. Range, we'll talk about range, but domain should be very easy for all of you. One thing I want to point out, and I kind of mentioned a little bit, but the numerator in that example, the x plus 2 over x squared minus 2x minus 3, played no role in it. Okay? The rule was no 0 in the denominator and no negatives under radical. Okay, so this here as a denominator that we have to worry about. We don't have to worry about the numerator. Now, that's not to say that that's always going to be the case. You could have a 2-for-1 deal where the numerator is x minus the square root of x minus 3, and the denominator is, I don't know, x plus 4. All right, then you have two things to worry about. Your numerator has to be greater than or equal to 0, and your denominator cannot equal 0. So you have to do both of them. So I would take x minus 3 has to be greater than or equal to 0, and x plus 4 cannot equal 0. Oops. X is greater than or equal to 3, and x cannot equal -4. So normally you'd be done. That would be your domain. But you do have to take a second and think about what we have as our answer here, because if that first part is true, that x is greater than or equal to 3, well then it's automatically going to not be equal to -4. So we can disregard this one because this one encompasses the whole domain. And that would be your domain. Now, hopefully, when I try to process this video, it's going to work and not crash. But who knows? Adios.